So my name is Jill Kowalchuk. I'm the Vice President of Project and Partnership Development for Cybera, and it's my pleasure to have the opportunity to introduce the speakers for this session. The format of the session will be each speaker will be giving 15 minutes, and they're only supposed to have 10 to 15 slides, so feel free to count. And as all of the speakers know, because they all have the pleasure of knowing me so well, that I am going to be keeping us on a strict timeline. So we have our whole iPad timer set up and all sorts of penalties if they run over the 15 minutes. So I will introduce each speaker prior to them talking. The first one will be Bill Appleby. Bill and I have known each other for a number of years now. He is the president of the Victoria Partnership for Advanced Computing out in Australia. And we've had the pleasure of having him speak at a couple of our summits, but today he's going to give us some interesting aspects on a cloud case study as it relates to some big initiatives that are happening in Australia.
Oh, thanks a lot, Jill. So, we started, okay. 14? Hang on, that's ridiculous. Okay, I'll be very quick. I'll briefly introduce VPAC.
You're going to have to use the mic or people on the web can't hear you.
Okay, I'll be pretty brief then. What I'll do is quickly go through who VPAC is, this project called the Virtual Australia New Zealand Initiative, and how it relates to infrastructure planning. Okay, briefly, VPAC, I won't use up any time on this. We're like sister organisations, but we're a little bit different. We're both state-based, we're both cyber infrastructure. The biggest difference is VPAC is now like over 10 years old. We employ about 40 technical staff, systems administration, software developers, engineers. We do a lot of work with industry. We get most of our money from contracts and services, so we're not a grant-based organisation anymore. We do get government support, but it's primarily for projects. We have a lot of major commercial contracts with people like General Motors, including General Motors North America in virtual engineering. We partner with a lot of companies in Australia like IBM, and I know DDN, who's a sponsor here. Okay, infrastructure. Now, infrastructure planning for large projects hasn't really changed much in the last few decades. It's generally done by white papers, consultancy, someone writes a report, you do a one-off study and model and simulation. If there's any disagreement with it, what the government usually does is throws it out and starts all over again, or simply says, well, we'll do it anyway. So what's wrong with the approach? One is the stakeholder engagement's very limited. It's difficult to get access to the data. Each project's a silo, and typically the government acquires or creates new data sets and does new models for each particular activity that it wants to do. It's also got, from a government viewpoint, a limited ability to manage risks. We've seen many cases where there are unanticipated side effects of projects, whether it's water or emergencies that don't get considered. Okay, so here's a couple of quick case studies. I want to dig a hole in my front yard. If you want to do that right now, you don't want to hit any power cables, or you don't want to knock off the internet connection which connects up all of Canada, which runs under your yard. So there are utility ways of getting data, but you've got to call, typically dial before you dig or something like that. They come out and they spray paint in front of your house. I mean, that's ridiculous. In the modern day and age, I should be able to stand out there with an iPhone or whatever, walk around and see an overlay, on the ground of where those pipes are. And if that's not where they are, I should be able to key in something, say, please fix it. Now, that's all there. Another case study, one that we're dealing with right now in the city of Melbourne. They want to put in a new train station. What they typically do is that they have some internal study by the Department of Transportation. If you want to get it, you get a 1,000-page document through Freedom of Information. Maybe they'll put up a movie which will show you what it's going to look like, but you have no ability to interact with it, to question the data, to see the assumptions. In VANSI 2020, there'd be a 3D interactive model created. You as an individual citizen could download it, look at it, view it, get an idea about how it would impact on you. If you're an authorised user, if you're an arborist, for example, you might want to look at tree planting around it. If you're law enforcement, you want to go around the station and look at crime prevention. Where should lights go? Where could criminals hide? You want to do a traffic flow impact statement and so on. So I think the demand for this is pretty obvious, the need for it. And the interesting thing is 99% of the IT technology to do this exists right now. There is nothing out there which we can't do right now. So what limits this is basically four things. One is difficulty of getting real-time access to GIS data sets, and we had an interesting discussion in the last session about that. The difficulty of creating 3D interactive movies requires game technology. Government and utility conservatism. Again, it's really interesting that some cities like Calgary are charging ahead, but there are a lot of cities that aren't. The other one is lack of a platform, because if you want to do this, every project is going to have to build its own infrastructure. So we're going to conquer all those. GIS data sets, I think this is a pretty well-discussed problem. There are a number of national projects going on in Australia. One is what's called the National Spatial Data Mart, which is sort of creating links between data sets, allowing people to export them. You can charge for them, it's up to you, involving the utilities and local government. The other one is government regulation, requiring utilities to make their data sets available to people. That's good. Carrot and stick approach, open standards, OGC and a number of other standards worldwide, in particular building standards. And there's a lot of work on emerging 3D GIS databases. That's significant. 2D GIS is there, 3D is coming. 3D interactive models, we bet the technology in this that's going to come from is going to be from gaming technology. Gaming technology is very advanced, obviously. If you've got kids, you'll know all about 3D game technology. I won't have to tell you anything about it, right? So we are leveraging and collaborating with those people. Conservatism, what we're arguing all the time is that these new models and new ways of doing things are an adjunct to existing planning, not a replacement, right? You can still use case studies, you can still have your consultants, but this is another way of minimising their risk. We're also very keen on what's called agile software development. We find that government is paranoid, afraid of multi-year IT projects which burn out bazillions of dollars. Agile development basically is about rapid deployment within 1 to 2 to 3 month cycles. Rapid feedback, build a first prototype. And finally, leverage off eager early adopters and case studies, people that have done this sort of stuff worldwide in other jurisdictions. Okay, lack of a platform is the key to all this to some extent. Each GIS project has got to build its own platform. So the solution is this national concerted effort called VANSI to build this as an open source project and to evolve it over time on a project by project basis. So in other words, if we built the infrastructure to do this for the City of Melbourne, the only thing that you'd have to put in, I guess, for Edmonton is you'd have to add an extra feature for snow removal, which is something that we... Whatever, you get what I'm saying, the common structure, common standards and so on. So this is the architectural model. I'm going to step back a little bit here. This is a standard multi-tier architecture. You've got population data, freight distribution data, road transport, rail, goes through a standard data access layer. These APIs are built for specific databases. Notice VANSI does not intend to host data for anyone. It is an interchange format. Third parties might aggregate data, we get involved. Then there's what's called an object layer where you build abstractions of things, like abstractions of a shipping container and so on. Some of these exist already. Then you go up to the model simulation layer where you pull in these pieces and components as you need them. Then you go up to an upper level API, which could be, ArcGIS if you wanted to go through that. It could be through a 3D web browser. It could be an overlay on 2D Google Maps. This is where it's at. Different interfaces for different people. That's the architecture. So how do we achieve this? Now, the thing is it requires a strong consortia. I mean, obviously it's a pretty bold initiative, and you can't just do it with IT expertise. You need the expertise of local government. You need the expertise of people who know about geospatial data. So we've formed recently, as in a couple of weeks ago, a new not-for-profit company with all these people as being co-stakeholders. CRCSI, which is the National Spatial Data Consortium in Australia. So all of the companies involved in spatial data, AAM, a lot of others, Urban Circus, all the state governments are involved in that. So we got all the GIS guys. Then we get NeCTAR, which is National ICT Australia, which is a consortium of ICT research organisations that includes CSIRO as well, Municipal Association of Victoria, and you've got us, we're the IT backroom boys. We've also got a pretty strong track record of engagement with state government, because you need to get this off the ground at what I call the state government premiers level. They're not going to listen to you otherwise because the Department of Transport will keep them away. So this is a fairly new initiative. It's early days. The website won't be up for another night or two until I finish it, actually until I get our midnight shift guys in Australia working on it. For now, contact me. We expect vansi.org will be up, .au, probably in about a week or so. Big key infrastructure projects. City of Melbourne has issued a 3D modelling initiative, a pretty large multi-year, multi-million-dollar project. They want to create essentially, I call it a 4D data model because they want to integrate all of the spatial data that they have from different sources together. The street level data, the building data, the data about what's underground as far as pipes and utilities go, and to have that evolve over time. Now, what do they want to use this for? Well, in particular for infrastructure planning, for new buildings, for assessment of things like shadows, overcast, and so on. For urban planning in particular, for the arborists, in particular, as a tourism application, you can see it'd be a gold mine because in some ways it would be like Google Street View on steroids, right? You could walk by and just see inside the buildings. The big one at the state level is what's called the Melbourne Intermodal System. Melbourne's a city of about 3 million people. It's the busiest port in Australia. All those containers come in at one point and they go out on essentially single trucks to single points across the city. And clearly that's super inefficient. What they want to do is a plan to locate inland ports, that is inland freight depots across the city, move the containers from the Port of Melbourne or other ports like Hastings and Geelong, move those containers out to what are called inland port locations where warehouses can be. But, you know, blind Freddie can see that to do that you need collaboration of the stevedores, the shipping companies, you know, the freight lines and all the rest of it. So it's not a project that even a government can do single-handedly, and you can't do it by issuing a tender because it requires all these parties to collaborate on information gathering. So we're constructing, you know, the proposal is to construct a model of all this to facilitate decision-making about where that inland port would go. And again, each of these build off similar sorts of reusable components in terms of data. So the Vanzi vision, the Vanzi project, this slide sort of says it all. You've got the real world here, then we've got data curation, data gathering from different sources, maps, buildings, models, plans, demographic population data. You want to be able to predict over time where things will go. Under a data management system with data assurance, services, validation and so on, which then lets you create like a 3D model of the city to explore that for, say, infrastructure planning like this Melbourne Intermodal project, right? It enables you to create like a course model here. This is a 2D Google Maps style model, but you can equally well with games technology create, you know, a model of Melbourne Port itself and show the movement of freight containers and all the rest of it off it. You know, that leads to then decision making, which then comes back to real world changes. I mean, that in essence is the, you know, the vision, if you like, of where we want to go with all this. Again, we have 2 or 3 projects that are sort of on the boil at the moment. We're looking to make this both national and international in terms of building infrastructure for, IT infrastructure for planning.
I'm going to talk about the DARE project, and which is, you know, basically talking about something that exists and that we've had good experience with. And then I'm going to talk a little bit about some ideas around where cloud computing can go in Canada and how Canarie can facilitate that. So let's start with DARE. There's a real problem in Canada. The ICT industry is dramatically declining. The number of venture capital investments that are in Canada is going down, as you can see from the graph. The same curve in the United States is more U-shaped, so we are not recovering from the dot-com bust. And so we've got a lot of work to do. We've got to find ways to stimulate innovation and move from research to commercialization in Canada. And so the DARE project is positioned to do that. The program looks something like this. So we have essentially a test bed for small to medium-sized enterprises. Those folks who don't have the capability to access the kind of network that Canarie can provide, small organizations who need this kind of infrastructure to test their products. So this test bed's been created. We are currently in pilot mode with this, and it looks like this. This is the architecture of the environment. The intention here is that we want to give lots and lots of Canadian small to medium-sized enterprises access to this test bed. The intention here is to let 1,000 flowers bloom, and hopefully the next RIM or the next Nortel will come out of this. By giving small to medium-sized enterprises access to this test bed, we remove a barrier to entry. So it makes it easier for them to develop their software and compete on an international stage. If it becomes more economically viable for them to use this environment and build their software, than folks in other countries who are trying to build similar software. It gives Canada a competitive advantage, and this is really important. So who will benefit from DARE? Well, it will start with the small to medium-sized enterprises, but it will grow. It will grow into the ICT research community throughout the research and education community in Canada, the universities and colleges. And then finally, multinational enterprises. So this is a place where multinational enterprises who have a presence in Canada want to take advantage of this facility. They will be able to do that. But that's after the pilot. We have to get the pilot finished first. So the results to date, we have folks from 8 provinces on the system. There are folks who are not on the cloud yet. So this gives them an opportunity to actually experiment with the cloud, to test the cloud, and most importantly, to learn from the cloud. And for us at Canarie, and I'm looking over to Mark Wolf over there, we've learned a lot about the cloud by creating DARE. So this is creating greater knowledge, expertise, and intellectual capital in Canada. There are folks that are looking to the cloud. Some of the organizations that are on the pilot are looking to the cloud, so this gives them the opportunity to experiment and test on it. And then there are some that are already using the cloud, but this gives them a better facility to meet their particular needs. There are, I believe, 23 companies on DARE right now, and several other on deck that are applying. I think it's another 8. Is that fair? So 23 using it, and 8 will be coming on fairly quickly onto the system. So the companies that are participating come from a wide variety of industries, and the great thing about this is that it's stimulating ICT in many sectors of the economy. There's a multiplier effect with ICT, and so $1 invested in ICT today can mean $3 of productivity gain in other areas, in other industries from that ICT gain. So, my favorite example, I see I'm going through this fairly quickly, so now I'll spend some time telling a long example. No, I'm just kidding. One of my favorite examples, though, is the gaming community. So let's say there's 2 or 3 people sitting in a basement writing a really cool, massive multiplayer game, and they have no way to test that. So they have no idea what the performance characteristics are going to be like on the large network. DARE gives them the opportunity to experiment, to see what the performance characteristics will be, and to see how their particular product will work in a network like this. So as you can see, there's a number of other opportunities, including things like insurance as well. So there's a number of opportunities across Canada to use DARE. These are some of the comments that we've gotten about DARE. Very, very positive. All the folks that are using it are very pleased, and it's just going really well. Now, it's a free service, so they should be happy. But when we move out of pilot, it will be probably a 50-50 cost sharing. I'm not committing to that, but that's probably what it will look like after it moves out of this phase. Okay, so that's DARE. I'd like to talk a little bit about cloud computing in general, and there are some economics that are going on with Canarie that I think will help, and economics throughout the higher education system in Canada, that I think will help in terms of growing the cloud and making the cloud more viable in Canada. So if we look at Canarie, the first point here, Canarie addresses a market gap. Right? So it provides a kind of network service that the big players like Bell and TELUS simply aren't interested in getting involved in. This is not a place where they want to build a network. So Canarie exists because we fill that market gap. Okay? Canarie also aggregates demand. So we make that market gap economically viable by bringing in a user community from across Canada of researchers and educators. And then finally, Canarie facilitates regional parity. So Canarie allows folks in Memorial University to have access to the same facilities as folks at the U of T. Right, so there's 3 key economic reasons for the existence of Canarie. And from a cloud perspective, the notion that we're addressing a market gap means that we're lowering costs for folks. So that means we're lowering costs for access to the cloud. One of the big challenges for researchers is that Amazon may be cheap, but getting to Amazon with large data volumes isn't cheap. So Canarie can help facilitate that. It can facilitate a lower cost access to the network. In terms of aggregating demand, we can become a collection point to help bring all of these users together to use the cloud service. And finally, with regional parity, we're going to make we can make a cloud service available to everyone in Canada on a shared basis, on an equal basis. So let's look at the notion of a shared service provider. And so if a cloud service is a shared service, then one of our big constituents at Canarie is the university IT organizations. They're all very different. They're like snowflakes. They have different degrees of centralization versus decentralization. They have different mandates. They have different funding models and so on. They're all very, very different. But the only thing they truly share is the network. Right? So the network becomes something that you can leverage to make shared services more viable. It truly is in and of itself a shared service, which helps us move us along the road towards a cloud service. Another thing that's going on in Canada is dramatic growth in research data. Okay, so we're seeing the humanities and social sciences, and I don't mean to insult anybody in the humanities and social sciences, but they are discovering computing in a new way. They're doing dramatic things with videos, with graphics, with images, and it's an explosive use of data for those folks. Medical and health sciences, we're seeing huge growth in 3D imaging and real-time diagnostics and real-time learning using the network. Traditional sciences and engineering are continuing to grow. Things like the square kilometer array are generating volumes of data that we could never have predicted just a few years ago. And then there's just the data management issues within research, backup, restore, and the notion of archiving and protecting research so that it can be recreated 10 years from now. So Canarie can help support that. What we're seeing with this data growth is increased demand on computing cycles, on network capabilities, and on data storage. And all of these can help or can be solved with better cloud services in the future. So let's look at that impact on research computing. So why are we running high-performance computing on campus? I believe there's 27 high-performance computing data centers on campuses. That's a large number for a country like Canada, so there should be some rationalization. I think Jonathan's in the room, so you would at least agree with that. So we need to think about how we rationalize those data centers, and if it goes from 27 to 2, 3, 4 data centers, we're really going to need the network, right? And we're really going to need cloud services to make that viable. Now, if 80% of the research computing isn't high-performance computing, and that number is debatable, but there have been some studies that have suggested that, that means there's a lot of computing going on in research in Canada that could fit on a cloud service, could naturally belong on a cloud service, but right now is scattered across all of Canada. So that brings up a couple of issues, and one is, for the most part, despite DARE and despite other efforts, the cloud really isn't in Canada, and that's a direct quote from Mark. I stole that from you, Mark. If it's not in Canada, that starts to drive protection of privacy issues, freedom of information requests, and issues around those, some of the things that Michael Geist talked about this morning, and also national competitiveness. So we need to think very carefully if we're going to support high-performance computing and increased research computing in Canada, how we can build Canadian cloud services. Another interesting thing that Canarie does is the Canadian Access Federation, well, Canarie and Cuccio. Two key features there are Eduroam and Shibboleth, and there are some things we can do to leverage those services. But ultimately, the point is that in a cloud environment, Canadian Access Federation can use authentication credentials from your local environment to allow you access to those cloud services anywhere in Canada. I'm running out of time, so I'm going to go a little bit more quickly. So Canada, the world's data center. This is an interesting concept. So what's unique about Canada? First of all, we have huge renewable hydroelectric resources. We have a lot of renewable energy that's available in Canada in various places. The farther north you go, the cooler it gets. So you don't spend as much money cooling your data centers, right? That's somebody nodding his head. You must be from Edmonton. And we also have the Green Star Network. So Canarie has invested heavily in the Green Star Network, and this is a pilot, but it has proven that we can run production services across multiple nodes, not only in Canada and the world, following the wind and following the sun. I didn't think it was possible when I first heard it, but we ran our annual general meeting for Canarie on this network, and when it got cloudy in Montreal, the services automatically moved to Calgary, where it was sunny and windy. And then finally, what can we do about taking advantage of this huge backbone we've got called the Canarie network? And the final point I want to make here is that manufacturing is the new agriculture. Right? What I mean by that is that those huge numbers of manufacturing jobs in Ontario, they're at risk. Those folks that are in the auto industry, those jobs are at risk. So Canada has to look for new industries, new economies. And so we need to think about things like DARE and how DARE can start to bring us into the new cloud world. And I just want to, again, mention the partners here, Cybera, University of Alberta, University of Sherbrooke, and Canarie, and that we do have 23 SMEs and we're growing. So the DARE pilot is an example of that success we can have with cloud computing in Canada. And so 1 minute and 16 seconds left on my last slide. We do have a cloudy future, but a cloudy future is a good thing. There are 6 drivers in Canada that I think can make cloud computing a very viable activity in this country. And a very viable business model. So it comes back down to economics. I think we can do this in an economical way that will help improve productivity and make Canada a better place for Canadians. Thank you.
So part of this talk that I want to give, I'm going to get out here and where I can see you all, is also touching on many of the things that Mark talked about, specifically the Canarie DARE pieces. And there's a timer just been set in front of me, which is running really, really fast.
It's counting to hundreds of a second.
Yeah, so I'll just get right to the point. That's really distracting. We know that internet access is being recognized as a fundamental human right. That's a terrific step forward. We'd also like to see compute recognized as a right as well. So how can we get the access to these things? We also know that Canada's ranking in terms of internet access is slipping. When I put this slide together a while ago, we were at 19th. Last figure I saw was that we were at 22nd, so clearly we're heading in the wrong direction. And it's pretty straightforward as well to see that no matter which commentator you're listening to, the economic success of the country depends on having good access to the modern tools of the 21st century. So what can we do about this? Well, let's think about infrastructure. In terms of infrastructure, this is part of how Canada was built. Initially, wagon trains heading west. I think every Canadian schoolchild learns the significance of this picture, driving the last spike. Without an infrastructure that allows us to move our goods from where they're produced to where they're consumed, we would have no viable national economy. In the early part of the 20th century, we got the highway system being built. And if you think about it, there's one highway from Calgary to Edmonton, not 4 in parallel, with people saying, no, please drive your trucks down mine, it's better than this guy's. We can't afford duplication of infrastructure in this country. We've got the 2nd largest country in the world, tiny little population. That means that we have to be sensible about how we build our infrastructure to make it economic. In the early to mid-20th century, we got CBC radio really addressing the fact that we have got this huge country with this tiny population density, infrastructure that reaches out and touches every part of the country and ties it together. And then in the latter part of the 20th century, you have institutions like Air Canada. Really, who else is going to fly to Tuktoyaktuk or Iqaluit unless they had a flag on the tail? Doesn't make economic sense to link those individual points, but if you don't link them, how can you say you've really got a country? You've got to tie it together with the infrastructure. So that all sounds well and good, but we're in Alberta. Why should we worry? We've got hundreds of years of oil and gas. Let's continue to rip and ship, and we'll be happy for years to come. But, the Stone Age didn't end because we ran out of stone. There are threats to the consumption of that standard part of our economy. People are recognizing that oil and gas is a very valuable petrochemical feedstock, and it'd be much more sensible to make things out of it than burn it. So that's changing. What's the other staple of our economy? Well, we've all got to eat. And for those of you who are visiting, Alberta's a great place to get a good steak. But even that's changing. If you look at 3D printing today, which is a fascinating field, and we'll probably be talking about that in a later session, and the addition of stem cell research, we've got researchers saying that they can take porcine stem cells and actually print meat. That's astonishing. The repercussions of that for agriculture, really, we can't overlook those. So the question is, are we simply going to see these trends and just let them go by? like the proverbial frog in the pot of boiling water with the temperature coming up, or are we going to do something about it? Well, let's think what it really means for our quality of life. Politicians tell us that what we want is jobs. But I don't know about you guys, but I don't really want a job. I happen to like the one I've got, so I'm happy with it. But I don't want a job per se. I want to have a nice quality of life. I want to have time to spend with my friends, go and enjoy the great outdoors. I think we all pretty much have the same thing. So if we want jobs as a way to enjoy those things, what sort of jobs do we want? Well, I personally don't want one of these jobs. And frankly, I can't have one anyway, because these jobs are all based on the cost of labor. They've long since left Canada and gone to Southeast Asia, where the cost of labor is low. If in fact what we want is nice, interesting, knowledge worker, high-tech jobs, good jobs, then why is it that we think that we can have them here? Government tells us that we should be an innovation economy, and I don't disagree. But what's the basis of thinking that innovation economy won't also go to China, to India, where they have people who are just as smart as we are, and far more of them? They've got more people with PhDs than we've got people in school. So I would argue that just as the manufacturing jobs where the cost of labor is low, the high-tech knowledge worker jobs will go where the cost of computing is low. And the cost of the computing is hardware plus software, plus networks, plus people, plus power and carbon. Hardware and software, we need to look to clouds. Networks, we have an amazing story in Alberta. People, we know that we have the talent. And there's a really good story in terms of power and carbon that's quite different from the oil sands development that are so fundamental to our technology just now. I'll skip over this one. This was to convince lesser familiar audiences that the major companies are going to the cloud. I think we know this. If you look at computationally intensive industries, though, the government of Canada has spent $1 billion over the last 10 years trying to get people to make movies in Canada. All that really happens is the Americans come north of the border when the dollar is low. Is that actually a good count now? Yeah. Okay, thank you. It's still going up. It means I have more and more time the longer I talk. The fact of the matter is that movies are now being made with render farms. If we can provide low-cost utility computational resources, we can attract companies making movies like Avatar, Kung Fu Panda 3, or whatever, into the province. Another trend that we've been hearing a lot about is very big data. Mark mentioned the square kilometer array, targeted when it comes on stream to produce a petabyte of data per second, 24/7, swamps everything we're even thinking about today. How can we possibly look at data sets like that without the advantage of some sort of leverage? And that leverage clearly is going to be artificial intelligence agents, agents that can immerse themselves in the data set, find the interesting leads that we don't even think of because we don't know what we don't know in these massive data sets, and then the humans follow up on it. So with all that going on, what claim can Alberta stake in this area? Well, here's Cybera's network. It's very useful, connects a lot of places, and it's getting more extensive all the time. But the hidden treasure that we have in Alberta is the Alberta SuperNet. Greatly underutilized. Between 2000 and 2005, the province spent $300 million putting fiber in this province into every small town, large city in the province that had a school, a healthcare facility, government office of any sort, or a library. Canarie, I think we're all very familiar with. Mark was just describing how extensive that network is. This all ties together. So if we look at where SuperNet actually exists, because many of us never see the networking components, here's a SuperNet point of presence in Pincher Creek. A nondescript box, you'll see some microwave towers on the side, or microwave dishes on the side. Those link it to a fixed area wireless access tower. Turn around from that fixed area wireless access tower, and what do you see? This gorgeous southern Alberta landscape that is absolutely littered, dotted I should say, because I rather like the look of them, with wind turbines. Some people don't like the look of them. I think they're really quite nice. This is called Windy Point for a reason, and there's more and more of these things being installed all the time. 600 megawatts going up to 2.2 gigawatts over the next 5 years. For comparison, here's the Old Man River Dam. That's just 35 megawatts. So this is a huge resource for green power. All that green power in this area ends up at this substation just outside Pincher Creek. Pincher Creek, a typical small town, a couple of thousand people. Average age is going up and up and up as people leave because they can't participate in the modern digital economy. If you look in the ditch just outside Pincher Creek, next to that big source of green power, what you'll see is this sign that says, "Caution, buried fiber optic cable, Shaw." But there's not just one of them. There's the Shaw one, there's the TELUS, the Bell, the SuperNet. All of the major fiber trunks in this province go right past the biggest source of green power, right past a town that's dying on its feet because the young people are leaving because they can't participate in the modern and digital economy. Could there be a better place to tie together cloud computing, green, and the ubiquitous access from the networks to show how this can affect the economy? So rather than just talking about it, here's what Cybera is doing about it. We've taken our network and we've cross-connected to the SuperNet. From the SuperNet, we can reach every K-12 school, all the municipalities, folks like Athabasca University who weren't on our network and are now connected. And then we've cross-connected that to the Seattle Internet Exchange and shortly through the Canarie peering initiatives to the New York and Toronto Internet Exchanges. When we flipped the switch on this, 40% of the traffic at the U of A immediately started moving over our lines and bypassing commercial internet. Same story with Athabasca, same story with the other institutions. And how am I doing for time, Joel? Is that one real? Yeah. Okay, good. All right, excellent. 5 minutes. Thank you. Plus marks, too. You're 2. Thank you. This gives us tremendous reach and allows us to aggregate the traffic. We've recently connected up Lethbridge School District 51, and approximately 65% of their traffic is moving over our lines and bypassing commercial internet. Why would you want to bypass commercial internet? Well, our internet rates in Canada are 1 to 2 orders of magnitude higher than the rates in the United States. Think what would happen if going down our roads in Canada cost 100 times what they do in the United States. How much traffic would we have moving over our roads? If we're going to be dependent on the network, as Mark has so eloquently laid out for us, that network better not cost 100 times more than our neighboring country. And by aggregating the traffic, we can bring the rates down far more close to parity with the United States. We also believe in growing the resources, so we're following a 4-step strategy. The first is connect, and I've just described the connections that we're doing. And I'm going to go fairly quickly here because of limited time. The next is to enable people. So enabling industry, participating with Canarie on the DARE cloud that Mark just described. In terms of classroom as a service, we are... Sorry, I just jumped past one. In terms of classroom as a service, we're taking the education community and putting resources in the south of the province at the moment and providing the ability to run classes at the University of Alberta, extending that to a few more universities and some high schools by January, and then pushing that out, finding ways to get the economies of scale of the cloud. And a community cloud. And we're going to be talking more about the community cloud in a session tomorrow, so I won't dig into it just now, but basically what happens if you take one of those small towns and provide all-you-can-eat compute on demand to people in a small town? How does that affect them? How does it affect the people in the rural areas? So we're exploring those. Once we've done that enablement step, what we want to do is grow those, as the third step, into utility-level resources. Utility-level resources for education, for industry, for the community. And then the last step, if we do have utilities, just as Amazon didn't set out to be the 900-pound gorilla in the cloud compute space, they just built an awful lot of excess capacity and then found ways to effectively sell that off. We can use the excess capacity, because we all live in one time zone, to provide resources for researchers in big data problems, for companies in computationally intensive areas, and attract them to the province. If we do that, that feeds the economy, it brings in the additional people and resources. That in turn leads to a bigger utility. The bigger utility attracts more businesses. We've primed the pump. There's nothing to stop the folks in India and China doing this as well. However, the prize goes to the first. The first mover advantage will be the jurisdiction that actually gets the benefit out of this strategy. Lastly, I'll say that this doesn't just apply at the provincial level. Clearly, if it works for the province of Alberta, it could also work for Canada as a whole. If you do look at our geography and consider just how vast this nation is and how sparsely populated many areas are, we're currently buying a fleet of these at $135 million each to establish our sovereignty by whizzing past various lightly populated areas at Mach 2, and you can see the little flag if you look very carefully and very quickly. If you spent the same amount of money as one of these on extending our wireless infrastructure and our fiber networks into the far north, the next one of these that goes through our waters, be it Canadian, be it American rather, or Russian, as our waters open up with global warming, saying that that's not really our territory, wouldn't it be nice if they got pinged as they went through saying, "Welcome to Canada"? the roaming rate might be $500 a minute, but you know, it's our territory and we should have our footprint on it. So with that, I think I'm just pretty much right on time. I'll wrap it up there. Thank you.
Thanks, Robin. Thank you, Robin. So I've just asked our speakers to come sit at the table so we can have mics for them all. And Jana's going to help with the microphone. So we will now open it up as Bill takes a seat.
I'll put my backpack down.
We'll find it. Oh, there.
I'll find it.
To questions. Robert.
So I heard the first speaker talk about the square kilometer array, or the second, Canarie speaker, sorry, and then Robin brought it up, and you know, I'd like to point out that the square kilometer array is not generating any data, nor will it until about 2019 at the earliest, and perhaps as late as 2024, and you know, I wonder why. I realize that the square kilometer array, from a point of view of a computer scientist, looks very sexy with the data volumes and so on, but I mean, one can make the case for big data based on all sorts of experiments that are much nearer term. So I'm just curious why you hang your hat on the square kilometer array.
I didn't intend to hang my hat on it. It was just oh, hang on. There we go. I got a blue light. I didn't intend to hang my hat on any particular. It was just an example that came to mind. If we look at what's going on with the Neptune work in you know, going out in the Pacific Ocean right now, the volumes of data being generated there are massive. You look at the SeaBrain experiment going on at McGill, again, massive volumes of data, and the list goes on and on and on. The big science projects tend to continue to generate massive volumes of data. But my favorite example, I will hang my hat on this one, is the example of the Large Hadron Collider, where if a high-energy physicist is downloading data on the Canarie network, and say they're an Atlas Tier 2 university, it'll take about a minute for the data to come down. And if they were to use the commodity network, it would take a whole day. Right? So that starts to give you a sense of the scope of data we're dealing with, and that the technology architectures that we've built can handle it now, but they're not going to handle it in the future. Right? So if you move from the Large Hadron Collider volumes of data to the kind of data we're going to see from the square kilometer array, that's where the future is going, and we need to ramp up for that.
I just throw in, you ask a good question there, Robert. I guess I would go to a classic Canadian analogy. We're trying to shoot for where the puck's going to be, not where it is right now. The fact is that when we look at the square kilometer array or the Australia SK Pathfinder or the Meerkat one in South Africa, they're starting to produce data, and when we see the possibility of big science projects dwarfing even the Large Hadron Collider flow, we really have to get our minds around what it's going to be, because we can't build these things overnight when they come on stream. So as much as anything else, they really fire up the imagination and make us realize just how large the challenges will be down the road.
Thanks. Other questions? James in the back.
I'm actually going to advocate for leveraging the SKA as fully as we can. The project is real, and the commitments are real from the, I think, 20 nations that are involved in the project. And Canada actually has a pretty big stake in it. One of the principal investigators in the project is at University of Calgary. That's Dr. Russ Taylor. And it's not necessarily for the benefit of all the primary data, the raw data that's going to come off that instrument, but the downstream data, value adding, image processing, visualization, all that kind of stuff. We could be the center of excellence for that, here in Alberta especially, because of the stake that U of C has in it. But this whole notion of Canada being the data center for the world, That's a very real opportunity as well. We're better positioned to capitalize on that than anybody, any nation on the planet. So even if the projects are, you know, off in the future some way, they are starting to generate data, as Robin points out. Take the aggregated collection, the whole kit and caboodle of research, advanced research, what's happening in industry as well. We're going to have trouble keeping pace with the demand for space. So let's get on it.
I don't think that was actually a question, but yes, I agree with you, James.
Mm-hmm. Are there any other questions from the audience? We'll just ask you to hold for the microphone so those on webcast can hear the question. Thanks.
Okay, so I'm interested in the first speaker's point about integrated 3D models on GIS, and I was wondering about your choice of format as opposed to Collada. I was understanding that this might be a standard or something close to it, and more generally ask you about whether there are similar efforts and what is the emergence of standards in this area. Thank you.
Thanks. The good thing about standards is there are so many to choose from. So we're working with, you know, whatever standards groups have standards like the OGC group and others, trying to build on top of that. In some of these areas, the standards are not good. And there are other problems too with the geospatial data for infrastructure, which is you often have to resolve geospatial data on many different scales, and you have to come up with schemes that enable you to restrict the piece of data that you're looking for. So we have a couple of sort of research projects in that domain. But in general, in the VANSI project, we are not trying to construct standards. We will go with whatever existing standards exist, but then also build adapters to be able to change the flow of data between them. If that, you know, because you can, seen experiences in the past where people can get very hung up on trying to define the, if you like, the perfect standard, but we tend to build on top of whatever exists. Thanks. Does that answer the question? Thanks.
I'll just add to that with Cybera's Water and Environment Hub project, we've had similar, when Bill was presenting, I was looking at the architecture diagram thinking, yep, there's a lot of similarities there. Anytime that you have to pull in from a large number of data sources, you can't hope that they're all going to be on one standard. So working closely with the GeoSense folks, we've managed to translate a lot of the data formats and so on and have that very functional, very flexible translator layer. Very few people just throw their data in a random fashion, but it still means you have to deal with a lot of different standards. And so the flexibility of whatever engine you have to be able to reach in and touch all the data sources in the format that they've been stored in is really key to making a data warehouse type project like that work.
Are these translators open source, or do you have to invest a substantial amount to start manipulating data?
Not quite sure I understand the question. Can you just repeat it again or in a little bit more detail?
The software for translating from one format to the other, what kind of software are you using? Is there open source? Are there open source choices?
It depends upon what you're coming from and where you're going to, but in general, for example, most of the, for example, tools which are out there for creating visualization will take hundreds of different formats of data. So there are a lot of open source and public tools for moving between them. It's when you get to more specialized data formats where somebody has built, you know, their own relational database table, their own schema, that you've got to sort of construct something, you know, typically by hand. But there are good tools out there right now which will, for example, take a relational database and, you know, generate wrappers automatically from it to let you import the data. .NET's E to F and Link to S come to mind, and then Hibernate and some others. So the problem of moving data from one format to another is not usually a showstopper. I'll just add one comment to that, though. The big problem we find in a lot of applications dealing with data is the quality of the data and the data curation. And if the data hasn't been entered in a complete format or it's been inaccurately entered or hasn't been tested, the effort required to clean up that messy data sometimes can be huge. I mean, my favourite joke is, where is the richest mineral deposit in the world? And the answer is just off the coast of Africa, just a little bit down from Nigeria. location 00, where people haven't bothered to enter coordinates. So, the problem then is if you pull that data in and you attempt to display world minerals on a map, you'll suddenly find this rich treasure trove just off the coast of Africa. So, so you have to have reasonably robust tools which can throw out data, which is not valid and not reliable. The data curation problem is the biggest area where we see that's a problem. This is a bit tangential, is in the medical domain, because medical ontologies and medical schema differ a great deal. So in the geospatial domain, you can sort of, if it doesn't look good, you can sort of throw it out or you can approximate sometimes.
Other questions? Over here, Jan?
Just in the spirit of this session and panel, you had just kind of started touching on it, but I was hoping you could speak more to what actually are the biggest lessons you've learned through the process of undertaking this kind of infrastructure.
Well, I'll jump in, I guess, first. For us, the biggest single surprise as we try and increase the footprint of Cybera was to realize the effectiveness of the Alberta SuperNet. There's a tremendous resource there that really wasn't being utilized to anywhere close to its capacity. And as we tie into that and extends our reach, it's been absolutely golden. And we intend to get a lot more out of it. So that's been our biggest pleasant surprise.
For DARE, this may not seem like a big deal, but what we've discovered is that when you offer a resource for free, folks don't want to leave it. Right? So as we move out of pilot, we'll have to start putting some parameters around, how long they're going to be allowed to be on it. And it's kind of like the tragedy of the commons. Any free resource is going to be abused. So we need to manage that a little bit more carefully.
And from our experiences in Victoria, running grid and cloud computing and so on, a couple of things. One is, I think the key one is that people and support are far more important than infrastructure. Governments tend to fund infrastructure, hardware, software, networks, and then just assume that once you put it in the ground that it'll work. So we've found time and again that you need to put more money in than you budget into people to really capitalise on the investment that you've got in the hardware, software, infrastructure. I think that's the biggest key lesson I've seen in cyber infrastructure and this type of area generally is, the people and having sufficient people on the ground to help people out, especially once you've got beyond the eager early adopters, is the critical thing.
Are there other questions from the audience?
Let's suppose that 10 years from now, Canada was successful in becoming one of the world-renowned cloud service offerings. If you had to pick one key success factor that got us there, what would it be?
You can have that one first, Mark.
Well, I'm just going to build on Bill's comment that it's about people, right? So if we think about the government, the Harper government's, can you hear me? The Harper government's S&T strategy around entrepreneurial advantage, people advantage, and knowledge advantage. What we're doing with DARE is driving all three of those. So by learning from what we're doing with cloud computing, we're growing the intellectual capital. By focusing on SMEs, we're helping to drive the entrepreneurial advantage. And by learning from it, we're creating an intellectual advantage. So, yeah, I think it fits nicely into, number one would be people, of course. I mean, that drives all of this. But it does fit nicely into the overall strategy of the Government of Canada.
I'm not going to disagree. I'll say it in slightly different words. If we find ourselves 10 years from now as the leaders, I think it will be down to political will. It'll mean that we actually got the message from thought leaders, from events like the Cybera Summit, going forward to our political masters and saying, yep, we're going to do this, and getting on with it, because there's no time to waste.
Being an Australian, I'll throw in a comment. A lot of it's, I would say in this particular area of cloud computing, I doubt that it's ever going to be what I call fully commoditised for at least the next decade. By fully commoditised, I mean the issue has got to do with the evolution in computing itself. It's also got to do with the issue of how do you put the compute and the data in the same place and solve the networking problems as well. And how do you build the services on top of it? So I think if it was fully commoditised, you could almost perhaps argue, well, maybe Russia has got as much advantage because they can dam up those monstrous great rivers that they've got flowing north. But I think if you can pick on this and say, look, it's clearly an international worldwide trend. Canada clearly has an advantage. And so if there's, as you say, the national will to do it, then there's clearly an opportunity to take an international leading position on it. And we're not likely to do that in Australia because Central Australia, in case you haven't noticed, is not a great place to try to cool things.
Thanks. Do we have any other questions from the audience? So efficient in my timekeeping. We can break early if there are no additional questions. Okay, well, with that, I would like to thank all of our panelists one more time. So thank you for the presentations, staying on time, and the interesting discussion at the end.